Good afternoon to all of you, and now we will discuss about the importance of cryosphere. Previous lecture was about the remote sensing and general principles of remote sensing, and you have listened and seen the uh, scholarly lecture from Jay Srinivasan, and predominantly he talked about the uh, atmospheric remote sensing, and we will pick up from there, as well as he has talked about the general principle of remote sensing, and we will pick up from there. And tomorrow we will talk about the remote sensing of snow and ice. But today we will talk a little bit, general topic, essentially because this is earlier you had very scholarly lecture, and we don't want to, clutter your mind with too much information. So this we will have, this is specifically designed um, for this lecture series about, we will
No?
talk about the importance of cryosphere. Arya, you can mute all of them.
Yes,
Did-
sir, I did. I did. I did.
Okay. So what is this is, we will, we will think, not moving. Okay, we will start from where we left yesterday. And yesterday we were talking about how much is a perennial ice on the earth, and how big, if it melts completely, what is really going to happen to sea level, and how thick, how much is volume stored in ice, and how much, if it melts and comes into the ocean, how much sea level will rise. So we have seen yesterday the one of the largest ice sheet on the earth is the Antarctic ice sheet, and which is almost 13.3 million square kilometer area, and it represents almost 34% of um, uh, total cryosphere on this earth, and it is almost 25 million cubic kilometer of ice is stored in it. And if it really melts, so its mean thickness is around 1900 meter, and its maximum thickness is about 4000 meter, almost a 4 kilometer. So you can see how big is the thickness. It is almost 4 kilometer. It is huge. Just imagine that, how huge that is, and it can really raise the sea level by 56 um, meter. The Greenland also has around 1.7 million square kilometer area, and it has mean thickness is around 1700 meter, and maximum thickness is around 3 kilometers, and it can raise the sea level by 7 meter. There are mountain glaciers. You remember most of the glaciers in Himalayas are mountain glaciers, and their area is approximately 1.1 million square kilometer area, but its mean thickness is much more lower. You can see here is it's around 200 to 300 meter, and some has 1,000 meter. Very large glaciers like Siachen can probably have ice thickness as deep as 1,000 meter, almost a kilometer, and it can increase the sea level by slightly less than 1 meter. And then there is the permafrost, about which talk about yesterday. So overall, if Earth becomes completely cryosphere free, it is quite possible that sea level will rise by around 64 to 65 meter. It is really huge rise in sea level. And there were time on the history of Earth, we will see some of the slides subsequently, that there were no glaciers on the surface of the Earth. So it is not something which is new for the Earth. Probably it is new since the arrival of humanity on this Earth. So, what are really its importance of cryosphere is, it is very important because snow and glacier melt help us provides water into Indian river system, and it leads to the hydropower generation. It leads to the irrigation and drinking purposes. Glacier melt also contribute to the sea level change. We have seen this ice earlier. There are hazards also. It can cause the avalanches, flood, and the icebergs. They can float into the ocean, creating significant hazard for the sea lanes. And we have seen in historically how iceberg has significantly affected and created disaster for the people who are traveling into the sea. Um, then climate, because its albedo effect, probably one of the slides which Professor Srinivasan has told you, is about how difference in albedo, if it is ice and if it is water, there's a significant change in albedo takes place, and it can modulate the Earth climate because water can absorb more energy, incoming solar energy, because it has a low albedo and the snow has very high albedo, therefore it reflects a lot of energy. So it can potentially, or it is modulating the Earth's climate. So there's a paleoclimate record also there. So we have seen some of the slide and we will elaborate on that in subsequently. And then there's the landscape erosion, landform, and it also affects because as glaciers move, they create a new landscape and they create the landform. So any of you have traveled into the mountain, you can see even in deepest high altitude region, you can see the very gentle and modulating mountains and rolling mountains you can see, and that is a probably example of how landscape is modulated by the glacial erosion, and it can also affect ecology of the region. So some of them are saying, Arya, it is not visible. Is it now? Is it? I have changed the slide. Have you?
It
Is
is
it
visible.
visible?
Yes, sir, it is visible.
It is visible. Okay. So the first Sankas, because so if you really look into the Himalayas, yesterday we have seen there are different mountain ranges into the Himalayas. There is the Pir Panjal mountain range, there is the Great Himalayan mountain range, and the Karakoram mountain range, which is sitting on the top. So uh, uh, the glaciers are also distributed all along those mountain ranges, but the concentration of glaciers um, is a different in different parts of Himalaya because in different and therefore the rivers which are originating from these different parts, such as Ganga, Brahmaputra, or Indus, has a different contribution which is coming from snow and glacier melt. Mm, So, so if you look into the thing, it is visible. If you look into the certain parts of high altitude region, which is where I have done the circle, you can see it is showing as high as 75% of snow and glacier may contribute into the stream runoff. So if it looks to the upper Indus River basin, which is originating into the China, coming from Karakoram mountain ranges in India and eventually going into the Pakistan, which has very high percentage of snow and glacier melt. And you can see here the Indus basin has approximately 60% in a total, which is contributed by snow and glacier melt. If you um, uh, come towards the western side, towards the eastern side, particularly Brahmaputra basin and Ganga basin, you can see that the amount of water which is contributed snow and glacier is relatively less. In Ganga basin, it is still less, it is just 20%, and Brahmaputra basin, it is slightly higher, which is a 25% is there. Um, so as we move from west to east, the concentration of snow and glacier melt is reduces, and that is but obvious. We will see some of why it is happening in some of the couple of slides, but it is also because predominantly because the amount of snow and glacier cover is relatively less as we move towards the east, as well as the amount of precipitation due to monsoon activity is also relatively very high. Mm, So it is also important for us to understand that how much is not only snow and glacier contribute, but how much they value, because we now know that food grain is important, because recent war, geopolitical situation which is created in Europe has created scarcity of food grain, particularly wheat grain, globally, and there is a food security is a major issue now. It was always there, but now this new geopolitical situation has created issues on food security. So you can see here that one of the food baskets of India is, as well as Pakistan, is Punjab part, which is a part of Pakistan, Punjab, Indian part of Punjab, then Haryana, then Western
Brother,
Uttar Pradesh. These are the region which produce significant amount of food grain. So it is also for
forest.
us to understand that what really happens to food grain production in Pakistan, because when the Indus River, it flows through China, through India, and enters into the Pakistan. At that top places, there is a canal network, and which is brought water into the part of Punjab of Pakistan, and it produces 96% of food grade. So any change in water availability can significantly affect the water security in Pakistan. If we come into the India, even that is also very important. So in India also, we have a Bhakra Rangal from here, canals are developed, and that canal network brings water to the Haryana and Punjab, and creating the green revolution in India, and it almost produces 26% of food grain, India's food grain, in that belt, Punjab, Haryana, and West, particularly Punjab and Haryana. And if you come to the Indus Basin and Ganga, come into the Ganga Basin, that another 37% is generated. Food grain is generated. So more than 60% of food grain of India are generated along the Indo-Gangetic plain, which some are extensively, particularly those who are in Punjab and Haryana, has high percentage dependency of snow and glacier melt. Some are relatively less in Ganga Basin, but they depend some extent on availability of water for snow and glacier melt. So it is important for us to understand it is not only water availability in these basins, but also it can significantly influence the food security of India and Pakistan. So that is very important for us to understand. But let us understand how much is glacial store water. I am just giving you a big picture as of now. We will go into the detailed methodology in subsequent talks, as well as when we discuss that particular topic about how to estimate the glacial store water or depth or volume of glacier. We will discuss that in depth. But this investigation done here at Divecha Center suggests that you can see that if you take into three basins, that Indus, Ganga, and Brahmaputra basin together, we have cumulative almost 3,236 gigaton of water stored in that. So this is huge water it is stored, but predominantly it is stored in Indus basin. You can see the more than half, it is almost three-fourths of water is stored into the Indus basin is 2,100 cubic kilometer. Then 556 kilometers in Ganga basin and 897 cubic kilometer into the Brahmaputra basin. So it's predominantly stored into the Ganga basin. And remember that these figures are in cubic kilometer, and if you really want to convert it into the gigaton, something else you need to do. So we will discuss that some other time. So what is really happening is, because as climate is changing, and as well as we were talking about why there is a less contribution of snow and glacier melt, because in the eastern part of Himalaya as compared to the western, we have to realize that what is the source of moisture for these regions, and in a way, what is the source of moisture for these glaciers. If you go into the western part of Himalaya, particularly Indus Basin, Jammu and Kashmir, Himachal Pradesh, you can see that predominantly it is westerly, that is western disturbances, which originates into the Central Asia. They come during winter time and do significant amount of precipitation in those states. So a lot of precipitation in form of snow receives during winter time. But when it comes to the central Himalayas, the westerly becomes significantly big, and they receive a very relatively less precipitation into the Ganga basin, particularly during winter time. But as summer progresses, the significant amount of push takes place. You can see here, push takes place in Indian monsoon, and there is also precipitation from Indian monsoon in high altitude. And remember, in some of the very high altitude, this precipitation is in form of solid, creating snowfall. So if you look into the Sikkim Himalaya or Nepal Himalaya, or if you look into the parts of Uttarakhand, uh, there is a significant amount of precipitation takes place in monsoon also. And because of that, the sensitivity to climate change is significantly different. And we have to understand that. Since the lower area of um, uh, Ganga basin and Brahmaputra basin receive the significant amount of precipitation in liquid form, there is significant rainfall there. Therefore, it is less sensitive towards the snow and glacier melt. And as compared to that, as monsoon move towards the western side and the part of Jammu and Kashmir, there is a relatively less precipitation takes place, and because of that, this region doesn't receive much precipitation in monsoon time and predominantly receives precipitation in westerly time, making them more sensitive towards the snow and glacier melt. So one of the key issues of cryosphere is snow cover. You can see that we have to understand glacier contribution into the snow and into the river system is important because that particular contribution comes when we really need it. But snow contribution, seasonal snow contribution is also equally important. So you can see that in the Himalayas, there's not much work is being done, but in to understand how much is the variability of seasonal snow and how it is going to change. Variation is taking place due to climate change and other things. So this is indeed one of the still areas where significant effort needs to be done. So if you look into the winter snow, particularly in Himalayas, is almost 1.59 million square kilometer area is covered by seasonal snow, and its variation is very large. So you can see that the winter time is almost 85% of area is covered by snow, and it keeps on melting as spring arrives, and sometimes it melts in middle of winter itself. And by the end of summer, only 10% area remains under permanent snow. Some of that is a permanent snow, some of that might be a glacier as well, yeah, and certain accumulation area of the glacier. So you can see that there is a large variability of snow cover is there. So as winter progresses into summer, there is a large variability on and as well as what really happens is on a time domain there is a significant variability from one year to another year, from day to day basis, on monthly basis, and on the annual scale. There is a large variability, making it very difficult to understand trend in the snow cover. So if you look into the R data, you will realize that it is not providing any trend. It is like, say, precipitation data, which has a large variability, and because of that, you may not get any trend. So there is a good trend in temperature because it's a relatively stable parameter, and there is no trend in snow cover. So if you really look into the last 20 years snow cover, you will find that there some people will say snow cover is increasing, some people are saying it is reducing, and that is only reflection of large variability into the on spatial domain as well as on temporal domain, which is causing difficulty in getting the train in seasonal snow cover. Um, then there's also time, if you know that we were talking earlier about the paleoclimate. That means there was a time on the earth that there was no glacier. So this is a record, you can see geological record of of uh, of the temperature on the planet. So you can see here that very early part of the geological history of the earth, um, and here x-axis there's a millions of years. So, and this is from 1960 to 1990 average. How much is the temperature difference? You can see that the early geological history of the earth, you can see earth was much more warmer than today. So Earth's temperature sometime was 14 degrees higher than today. These all records coming for careful analysis of different proxies on the Earth. That means you have a sediments, and from where you get this temperature and precipitation by using some of the proxy parameters like foraminifera and other things. You can get it in that. So you can see that early part of history of Earth, and probably that is because of very high concentration of carbon dioxide, and it came because of the huge volcanic activity in the early phases of Earth was taking place, which is around between 500 million years ago. So slowly, as we move into the Earth history, and as we move further, then you can see the certain part of Eocene, Oligocene, and Miocene. There's a reduction in Earth's temperature that start to take place, probably reflection of relatively reduction into the volcanic activity, and sequestration of carbon dioxide is started to take place into the ocean. So it continues even in Pliocene. You can see that in a Pliocene also it reduces, and it has come a certain stage where in the Pleistocene you can see here that small variations is there, clearly suggesting that that is the time when Earth has started to experience the various phases of glacial and interglacial phases. So many of you must be asking questions that when the early history of Earth, that means it is a very early history of Earth, why there was no this part of Earth where and Miocene, Eocene, Paleocene, and all other times where there was very high temperature and there was no glacial and interglacial period. Only when we enter into the Pleistocene phase, then the glacial and interglacial phases started to happen. But one of the key things from this, you can see that when it comes to the time, this is a phase. When you come into the Holocene, this is the phase where temperature is remarkably stable. So this is a unique phase on the Earth, and that has created relatively for almost last 10,000 years, there's a remarkable, remarkable stability on the temperature of the Earth. And because of that, human civilization could prosper on the Earth because we don't have. And then eventually, you can see here now, there's a sudden increase. You can see that sudden increase is likely to take place, and that is where these we call is, and now many people call is Anthropocene, where the Earth's climate is modulated by the human being, and therefore it is thought to be Anthropocene. So many of these records, some of these records are coming from sediment, but some of these records are coming from ice sheet, which is the Antarctic ice sheet. So it is indeed very important for us to understand that glaciers preserve past record and how it is done. You have seen that in yesterday's talk of Professor J. Srinivasan. So it is also important for us to understand as and in a glacial if you really look into globally, we will go into the Himalaya specifically subsequently later on. But if you look into the globally, how much is change into the um, into the mass loss of glaciers is taking place. If you look, this record is from 1950 onwards, 1950 to 2021. You can see that this record is there. But this is, remember, with reference to 1976. With reference to 1976, it is giving cumulative value of relative change. So probably 1976, you have over here is a zero mass balance. It probably means only artifact. But even then, before 1976, glaciers are having much more healthy cumulative mass loss. Glaciers were making gain, and you can see that mass glaciers have become negative since then, 1970. And you can also see that there is a sudden drop in a slope, particularly in 1990s onward or sometime in mid 80s. You can see that sudden drop in slope eventually, clearly indicating that acceleration of mass loss is taking place in a last couple of decades, and numerous investigations suggest that this is really a global observation. So another issue which we were talking about, the albedo. So what really happens is, this is albedo is, many of you are aware, nothing but the ratio between the mm, outgoing solar radiation by incoming solar radiation. So albedo of snow and ice is very high. So it really reflects a lot of energy which is coming on the earth, and since it is a reflected energy, it is not absorbed by the carbon dioxide. And you can see some of the rock here which has blackish in tone. So these, if it is that radiation is coming in a visible and near infrared part of electromagnetic spectrum, where there is a peak of incoming solar radiation, this energy can be absorbed much more efficiently if the rock is exposed on the surface, and then that can be emitted again, and that is emission takes place into the thermal band and creating that is absorbed by carbon dioxide and creating greenhouse effect. So that is how the snow and albedo is very important, snow albedo in modulating temperature. You can also see here how landscapes are modulated. You can, this is one slide, you can see here that this is a glacier ice. You can see this is a glacier ice, and sorry, this up to this point is a glacier ice. So glacier ice is like this, and below that there is a water, and you can see these are moraines. So the entire landscape is really modulated, changed by the glacier, and it is creating a very different. Uh, it is also important for us to understand how glaciers affect the ecology of the region, because you can see here is this is a snow which is fallen on the vegetation. So eventually with time, this is photograph was taken immediately after the vegetation snowfall. So they are it has very high albedo, as well as it is on the leaves of vegetation. But over a period of time, because of wind action and various things, it will fall on the ground, and there will be a snow cover below the forest cover. Do I have a picture? No, we don't have. So there will be vegetation below that, and it will slowly melt. It is not going to melt very fast because of the modulation of temperature, because the direct solar radiation, because of the vegetation doesn't reach to the bottom of vegetation very fast, so it will slowly melting, and because of that it rejuvenates. It provides water to the vegetation for longer period. The melting process is slow, and because of that it filtrates into the ground, and creating better aquifer conditions, and it lasts much longer, the mountain spring. So it is very important for us to understand how long this can last, and this can significantly affect the ecology. So we will look some of the slides later on this issue. It is also for us important to understand as glacial retreat, they create the new risk for the society. So some of these risks, we will look into that now. So we have now recently in the last year in January, February, there was a huge flash flood in Rushiganga Valley in Uttarakhand. So flash flood from hanging glaciers and landslide. There's a huge rockfall which is below it, landslide. It can create new risk for the people. There will be also significant landslide into the glaciated terrain, essentially because when the glacial retreat, they leave behind the moraines. And moraines are nothing but the loose material of rock and soil. So yeah, under numerous environmental conditions, they will fall, creating a temporary lake, and that is precisely has happened in Uttarakhand when Kedarnath tragedy has took place. So then there will be also flash flood from the glacier lakes. Then there will be snow avalanches. The differential glacier mass in Indus Basin is another issue, and the early melting of snow and vanishing small glaciers could be a major issue. So some of these ideas um, we will discuss now how we have come to the conclusion that idea. You will know that when you complete this course, because there will be a lot of issues, how methodology is adopted. Some of these exercise you will do. The first thing first is um, there is a significant change into the mountain taking place, and that is why glaciers are retreating. So one thing we should know is how much temperature changes are taking place into the mountain. So if you really look into this picture, you can see that uh, this picture has a histogram of from 1951 to 2016, and it has all over India temperature change, temperature anomaly. It is giving temperature anomaly, and it is giving over Himalaya. There are two different geographical regions shown, and this work is done by Indian Institute of Tropical Meteorology. And you can see that early part 50s until 70s, 75, 76, you can see in this part, actually Himalaya was much cooler than peninsular India. That is very important for us to understand that in between 50s to 70s, for that 20 years or 25 years time frame, Himalaya was much more cooler than the rest of the India. But if you, as we move towards the 80s, you can see here in this time frame, Himalaya is much more warmer than rest of the India. So what it really means? It means that as we move higher into the atmosphere, the cooling effect is also amplified, and the warming effect is also amplified. It also means that when we have a Paris Agreement where we said that global temperature will stabilize at 2 degrees Celsius, it really means in Himalaya it is a 3 degrees Celsius. But it is not the only temperature which is changing in Himalaya. There is also precipitation pattern is also changing in Himalaya. This recent work is done by Defense Research and Development Organization, suggests that uh, there is no significant factor in the change in precipitation, but there is a significant increase in the liquid precipitation and proportionate decrease in a solid precipitation. So we have two issues on hand. The snowfall amount of snowfall is also reduced in Himalaya, as well as the rise in temperature is much higher than global mean. and creating this anomaly where most of the Himalayan glaciers are retreating. So we will see that how retreat is going to affect the um, various issues on that. How it can be included into the system to understand climate change and its impact on glacier. We will look that into a couple of other. You will do some exercise on that subsequently, so you will get the idea. So let us understand what it really means to some of the regions of Himalaya. It means this is a work which is done Spiti Basin in Himachal Pradesh. You can see that by middle of century, if you use the RCP 4.5, remember RCP 4.5 doesn't mean that this is most likely to happen. It is not the extreme case where RCP 7 is an extreme case, but this is much lower than that. Almost 60% of glacier will disappear by mid of century, and by 2070 almost 66% glaciers will disappear in Spiti Basin. Remember, this estimate is only for Spiti Basin, and there's going to be a time different on time domain. There's going to be a significant change in a glacial loss. We will visit that issue a little bit later on. But what it means? It means that most of the small glaciers into the Himalayas, particularly in Pir Panjal mountain range and Great Himalayan mountain range, likely to disappear by 2017 or mid of the century, and this can significantly affect the communities which are living into the mountains. So this is one small community. It's Kumo village in Spiti Basin. Remember, these are very prosperous villages. They have very high-end agriculture, and they are supported by small glacier adjacent to that. That means this water is directly coming into their agriculture field. Remember that that does not mean even if this glacier disappear, there will be some water in a major river such as Spiti. That means we require now additional investment to make sure that these communities are supplied by water, and that is very important. Another key, so all small mountain communities are likely to be very vulnerable in future, and we require a definite plan to make sure that these communities are supplied enough water, either by the way we do in peninsular India, either by having lift irrigation scheme or by some other method. We need to address this issue. So that means there's additional investment is needed into the to sustain water security of mountain community. There is also on larger scale, this is the work which is almost 1.5 year back published in Nature when I was a co-author in this, to understand the vulnerability of river basin. So remember one thing, vulnerability is very idea is quite different. That does not mean how much of course, it means that how much dependency of snow and glacier means, how how that source of water going to change in future, then what will be the requirement of community which depend on that water, and what is the governance structure by which government's ability to modulate the requirement. All these factors come into the picture, and then we estimate the vulnerability. Even though cryosphere are everywhere, that means you can see here they are in Rocky Mountains, they are in Andes, they are in Himalayas as well. But vulnerability, and they are also in Alps. But vulnerability is highest in our part of the world, and particularly this Indus Basin is highly vulnerable because its dependency on water by snow and glacier is very high, and relatively the vulnerability of Ganga and Brahmaputra basin is relatively less because we receive a lot of water from monsoonal precipitation in Ganga and Brahmaputra basin. And top of that, it is so that upper Ganga. Indus Basin is going to be highly vulnerable, and we need to understand, address this issue. So, as of now, this is one of the most successful treaty, which is between the uh, uh, Indus Water Treaty, which shares water between India and Pakistan. And however, even though China, it originates from China, Indus Basin, but China is not part of this thing. But as far as the Indus Basin Treaty is concerned, uh, uh, so uh, so what really, there are, it is divided into two parts, and one part which is the eastern river basin in which Satluj, Beas, and Ravi, and another part is the Chenab, Jhelum, and upper Indus River basin. Uh, so, uh, as per Indus Water Treaty, this eastern river, which is Satluj, Beas, and Ravi, is exclusively given to India, and so India can use this water from this river basin, and Chenab, Jhelum, and Indus is given to the Pakistan. So there are some rights of India also there, but predominantly this water can be used by Pakistan. So at the time of when Indus Treaty was formed, that is 33%, 33 million acre feet. That means 16% of water was given to India, and 84% percent of water, that is 177 million acre feet, was given to the Pakistan. So that was the idea at that time. And if you really look into the glacial store water, this proportionality is not like that. So the eastern river basin has only 5%. You can see here, this region has only 5% of glacial store water and 95% of glacial store water in a western river basin. So that is when the treaty was written at that time. Probably there was no idea about the glacial store water. So even though at that time the proportionality between, you can see here, is between 16 to 18%, but 95% of glacial store water is in western river system. So having said that, as time, if you look at now, the glacier loss is a significantly, most of the glaciers which are located in are significantly losing mass. Here also losing mass, but there's a large glaciated area which is in eastern Karakoram is really not losing mass significantly. So they are relatively stable, and that is called the Karakoram anomaly. So it is quite, it may not remain for long, but might remain for some more time, this Karakoram anomaly. And by end of century, if you look into the data, it suggests that most of the glacier, 85% area, will be lost in eastern ravine, and only 35% will be lost in a western river basin. So creating some sort of anomaly on water availability, and this can probably bring policymakers again on drawing room to understand how we can share the water between these river basins. So in that sense, it is important for us to understand how glaciers are changing, what influence it is going to have on water availability, what issues it can create in transboundary region, basin, and it's not only transboundary within the country, how you are going to share the water, that is also going to get influence in future. I was talking about um, I was talking about the vulnerability of mountain stream, which is very important because you can look into the pattern of snow and glacier melt, and you can see here some of the basins which are located in low altitude, such as Ravi Basin, can significantly started to melt snow in the middle of winter. What it means is that your snow will depart much earlier in future, creating a difficulty and vulnerability for mountain stream, as well as um, uh, um, uh, what you call it, the mountain spring can be also dried much earlier, creating ecological issue about which we talk earlier. There's also huge hydropower development is taking place into the mountains, and you can see that HKH region has almost 800 million people, and mm, there is a huge potential is there, and some of this is realized, some of that is not realized. Huge realization has taken place um, into the China, and it is being developed in other parts of Himalayas to hydropower stations. So that is also going to get affected in future, as not only to total water availability will change, it will also change how water availability, seasonality of water availability will also change. So some power plants become very profitable. Some power plant can be can become less profitable. So there will be winners and losers on this ball game. So it is very important for us to understand how future is going to create some winners and losers in this ball game. It is also possible that there will be a new lakes will be formed into the Himalayas, and this you can see here that uh, generally, because the when glaciers is flowing, it flow of glaciers is not parallel to the surface. So some places it is submerging velocity, and some places it is emerging velocity, and because of that, some rocks which is collected is the zone of plucking. So rocks from head wall is coming, and they create the abrasion and making it possible to have a depression. When glaciers retreat, then the depression is filled with water, and then you have glacial lakes which are formed. It is also possible that this is one picture which I have taken in Himachal Pradesh in Spiti Valley. You can see that this is a hanging glacier, and you can see here how new fisheries develop. So there is glaciers is hanging, and it is quite possible that under certain critical condition, this entire mass can fall down, creating flash flood. It is, and that is precisely has happened in Rishiganga basin in February 2021. You can see here there are some cracks are developing over here. You can see below that, and this is on February 8th. This completely has vanished and creating a huge flash flood. Remember that entire mass has now fallen down and it has moved downstream to get the flash flood into that. And now there are techniques by which we can estimate how much is the volume. So by using some of the techniques which you will learn during this course, how to estimate, we have this is a laminar flow method. By using this method, we have estimated that 8.6 6.86 million cubic meter of volume was there, and you can take event and then you can say total volume of total mass which is around 25 million cubic meter came down, where you have digital elevation done before the earthquake, before this event happened and after the event happened, and you get the difference. And some technique can tell you how much is ice in it and how much rock in it, and then you can estimate that because of the presence of this so much ice in it, the liquefaction has taken place and huge flash flood has taken into the valley, and destroying some of the power plant and killing large number of people in downstream. In addition to that, there will be a rapid movement of snow and ice, which is causing avalanches. Originally, avalanches were not that many, or they were not, people were not there, but now there are a lot of people staying in high altitude region, creating that this is one of the Niti Valley disaster in April 23, 2021, suggesting that this could be a risk for people who are trying to stay during winter time in high altitude regions. So understanding avalanches is also very important. And to do that, and that generally takes place because of the formation of cantilever structure. You can see here, this is a photograph which is I have taken. This is a cantilever. You can look along this, below this line, and you can see that ridge line is somewhere here, and this due to icing, this structure has moved um, much more ahead of its ridge line, and because of that, this cantilever structure can collapse because of its own weight, or if there are some skiers go there. In India, not many skiers go there, but it can happen quite often in European countries. So that can collapse and creating a huge avalanche downstream. So it is very important for us to understand how this is happening and creating flash floods. So if we can really look into this, that there are numerous mm, issues which have created this because of the climate change and changing glaciers and cryosphere. There are numerous issues. Some of these issues we will try to address in our talk. You will, whatever conclusions you have shown in a present talk, you will understand the methodology of doing that, or the science behind this. You will understand in due course of time, whether it is formation of lake, how it is done. You will understand it. If you want to know how differential mass balance in Indus Basin, you will know how to do that in mass balance in a different basin. So some of these ideas which is presented here is based upon our work, as well as work which is done globally in uh, this. mm, So we will explore that in due course of time. So with this, I would like to thank you, and if there are